Hi everyone, welcome back to the channel Talking Books. In this video, we are going to talk about significant figures. You might have read this word significant figures in the last line of a question where it is given that the answer is required in two significant figures, three significant figures, or four significant figures. Then what are these significant figures? If we talk about the definition, we can say that significant figures are the meaningful digits in a number that help us understand how precise a measurement or calculation is. Let's talk about the rules for determining significant figures. Number one rule says that non zero digits are always significant. For example, we have a number 1, 2, 3, 4, and 5. There is no zero here, so we can say that we have five significant figures in this number. The second example is a decimal number, and we cannot see any zero here, so we can count the numbers present here as 1, 2, 3, 4, and 5. Hence, it is having the five significant figures. Let's talk about the rule number 2. It says that zeros between two non-zero digits are significant. You can see this example 3.007. Two zero are present between number 3 and 7. Hence, these will be also significant. Therefore, we can say we have four significant figures in this number. In the second example, we have a number 1002. These two zero will also be significant and hence total four significant figures we are having. Now, let's talk about rule number 3. It says leading zeros are not significant. Leading zeros are the zeros that are present left side of first non-zero digit. In 0.07, these two zeros are the leading zeros and these are not significant. Hence, in 0.07 we have one significant figure. In second example, 0.0027 we have two significant figures. Third example, 0.000435 we have three significant figures. I hope this is clear. Coming to the rule number 4, we can say trailing zeros in a number containing a decimal point are significant. What are the trailing zeros? We can say these are the zeros that are present towards the right hand side of last non zero digit in a number. For example, in 100, 1 is non zero digit and the zeros present towards the right side of this 1 will be the trailing zeros. Now, if we want to find out the number of significant figures in this, then what we can say? Since there is no decimal point, therefore these trailing zeros will not be considered as significant. Hence, there will be one significant figure in this 100 number. Now look at the second example, 100.0. We have a decimal point over here. Therefore, we can say all the trailing zeros will be significant. Hence, the total significant figures present in 100.0 will be 4. 1 is significant because of rule number 1. Now, in the third example, we have 4 trailing zeros and total 5 significant figures will be present here. The fourth example, 135.40, this 0 will also consider as significant. Therefore, this also we have 5 significant figures. Let's see the rule number 5. It says that exact numbers like counted objects, defined quantities have an infinite number of significant figures. For example, 5 balls or 50 eggs. These will be having infinite significant figures because these are the exact numbers. And we can represent them by writing infinite number of zeros after placing a decimal. If you see, the 5 can be written as 5.000. Here, total 4 significant figures are present because these are the trailing zeros and we have a decimal point. I can write 5 as 5.0000. Now, I have increased one more zero, so the total significant figures will be 5 here. It can be written as 5.0000 and 0. This number will be having 6 significant figures. I hope this point is clear now. Coming to the next point, it says that in numbers written in scientific notation, all digits are significant. For example, we have number 4.01 into 10 raised to power 2. We need to ignore this 10 raised to power part and we need to count the digits in this number. It is 4.01, so we can say 1, 2, and 3 digits are present. So we have three significant figures in this number. Here we need to ignore this part and we can count the digits present here as 1, 2, 3, and 4. This will be having four significant figures. If you want to learn how to convert any number in scientific notation, then you can see a video on my channel. I will also provide link in the description box. Now, let's learn about addition and subtraction of scientific figures. We are given with an example. We will take this example as a reference and will try to understand the concept. Here we have 12.11. We need to add it to 18. On addition, we are getting the answer as 30.11. But here you can see the answer is given up to one decimal place. Why is it? Because the rule says that the result should have the same number of decimal places as the number with the least number of decimal places in the operation. Here in 12.11 we have two decimal places and in 18.0 we have one decimal place. This is the least decimal place, hence the answer will be concise to 30.1. If you want to tell how many significant figures in this, then say we have three significant figures in 30.1. I hope this point is clear now. Now, let's learn about multiplication and division of significant figures. Here, the rule says that result should have same number of significant figures as the number with least number of significant figures in the operation. We are having this example 4.56 into 1.4. 4.56 is having three significant figures and 1.4 is having two significant figures. According to this rule, the answer should having only two significant figures. On multiplication, we are getting this answer 6.384, but we need to round off it up to two significant figures. On rounding off, the answer will be 6.4 and this will be having two significant figures. This will be the correct answer of this question. Now, let's learn how to round off the numbers. We have three simple rules for this. With the help of example, we will try to understand the rules. The first example says 4.532. We need to round it off up to two significant figures. So we need to drop these two digits 3 and 2. The rule says if the digit to be dropped is less than 5, the preceding digit remains unchanged. Since 3 is less than 5, so the preceding digit will remain unchanged. Here the preceding digit is 5 and we round it off as 4.5. Now coming to the rule number 2, we have a number 4.576. We are asked to round it off to two significant figures and the answer given here as 4.6. How this happened? Because the rule number 2 says if the digit to be dropped is 5 or more, the preceding digit is increased by 1. Since we need to drop 7 and 6 here, 7 is greater than 5, so we need to add plus 1 in the preceding digit, that is 5 here. Hence, the answer will be 4.6. Now, the rule number 3 says if the rightmost digit to be removed is 5, then the preceding number is not changed if it is an even number, but it is increased by 1 if it is an odd number. Let's see the example. We have 6.35. We need to remove the 5 to round off this number. Then we can write it as 6.4 as the preceding number is an odd number. If we are having 6.25, we need to remove the 5 to round off this number. Then we can keep it as 6.2 because 2 is an even number. This is all about the rules of rounding off the numbers. I hope you understood all the rules clearly. In the next video, we are going to solve the NCERT problems based on significant figures and scientific notations. If you have any doubt, do let me know in the comment section. And don't forget to like, comment, share, and subscribe my channel. Thank you very much.